Today, we're going to integrate 1 over 1 plus e to the x. So to do that, we use a u sub. We'll have u is equal to 1 plus e to the x, the entire denominator. So we differentiate this thing, we'll get du over dx is equal to just e to the x. So rewriting this in terms of u gives us u minus 1. So now we can kind of think about what should dx be. It's going to tell us that dx is going to be equal to du over u minus 1. So let's rewrite everything in terms of u now. Now the integral 1 over 1 plus e to the x is just 1 over u. And our dx we replace with a du over u minus 1. So now we've got this fraction involving 1 over u and 1 over u minus 1. So we'll try and rewrite that as partial fractions. So this thing is equal to a over u plus b over u minus 1, i.e. something and something over the two denominators that we have. So this tells us then that our numerator 1 on the original integral is going to be equal to a multiplied by u minus 1 plus b multiplied just by u. So the only constant term we have is this minus a. So what that tells us straight away then is that a is equal to minus 1. So now then, when we look at the multiples of u, we have 0 on this side, au plus bu. So a and b have got to be the same value, but as the negative of each other. So therefore b is going to be equal to 1. So we can rewrite our integral again. It's going to be 1 over u minus 1, subtract 1 over u, all integrated with respect to u. These then are nice and simple. It's going to become the log of u minus 1, take away the log of u, plus a constant on the end. And now when we substitute back in our value for u, we're going to have the log of u minus 1, which is just e to the x, minus the log of u, which is 1 plus e to the x. We still have our constant on the end. And now then we can see this first term is going to become just x. So the final answer is x minus the natural log of 1 plus e to the x. Again, plus a constant.